All right. Okay, so section one is minerals, earth as jewels. And we are going to start defining mineral. When first and foremost, we need to understand what a mineral is. Okay, so what is a mineral? The definition that we have in the book, and you can read it over there. Minerals are inorganic solid materials found in nature. Inorganic means they are not usually formed by plants or animals. Minerals are all over, all over the planet. So you can find minerals in your kitchen, in your living room, in your bedroom, and um, many different places in your house. Yes, Emilio, go ahead.
Mister, what page it is?
166.
Okay, thank you.
Welcome. All right. So, minerals are the solid materials found in nature. For example, you are going to drink some water today, and you are probably taking a glass or a cup. You know that is it comes from a mineral. The cup, it comes from a mineral, and so and many other things in your house, right? So we are surrounded by minerals. Something else that is important to know is that the particular chemical makeup and arrangement of the atoms in the crystal of a mineral is unique, which means every mineral is different from the others because the atoms in the crystal are unique. All right. And some people often get confused when it comes to talking about rocks and minerals. Most people think they are the same thing, but they aren't. Okay. Rocks are actually made of two or more minerals. All right. So, but a rock itself, it's not a mineral. It's made of minerals, two, three, or more minerals. Okay. So we need to keep that in mind. All right. Each mineral has unique characteristics we can use to identify it. We are going to go over some of the physical characteristics or physical properties of a mineral. And in order for us to identify a mineral, it's not going to be like a very easy to identify a mineral, especially if we are living in a city because we are not, in contact with actual mineral. And but we can still learn how to identify by looking at the characteristics. All right. And something very important is that so far there are more than 4,000 minerals identified on Earth. All right. How do minerals form? Good question. They can form in different ways. There are several ways by which they can form. The very first one that we are going to study is um, this way. They can form from melted rock inside Earth. What is this melted rock called? Magma. All right. So, how does this happen? As magma cools, atoms combine in orderly patterns to form minerals. Okay, so this is the first way. They come from magma inside the Earth. All right. What is the other one? When lava reaches Earth's surface, minerals can form as well. All right. Who wants or who would like to tell me how can this happen? The second one, when lava reaches Earth's surface. Emilio.
When lava reaches Earth's surface, it the magma can not the lava can cool and make obsidian.
Yeah, producing minerals, right? But my question is actually, how does lava reach Earth's surface? What is an example of lava reaching the Earth's surface?
By a volcano.
Exactly, by a volcanic eruption. Very good, Amelia. Thank you very much. And before I continue, I would like to ask another question. What is the difference between magma and lava? Who wants to tell me? Does anybody have an idea?
I think lava is liquid and magma is solid.
Solid. Okay, thank you very much, Jared. Who else? All right, when we talk about magma, we are talking about this melted rock inside the earth, okay? And when we talk about lava, we are talking about the same melted rock, but on the earth's surface, right? Through a volcanic eruption. All right, another way in which minerals can form is evaporation. Evaporation can also form minerals. How? For example, salt crystals appears when seawater evaporates. During the evaporation process, when all this water is going all the way up to form the clouds, okay, and the salt which is in the seawater, appears, right? So because only the water particles go up to the clouds, right? But the salt crystals will separate from the water. All right. So that's another way. Another way it's precipitation. Precipitation can also form minerals, right? How? Because water can hold only so much dissolved material. Any extra separates and falls out as solid. Um, a good example is you can see it in your book. There are large areas of the ocean floor covered with manganese nodules. These are formed as a result of precipitation. And it also says that this metallic spheres average 25 centimeters in diameter, and they crystallize directly from seawater containing metal atoms. So that is a way by which precipitation can form minerals too. All right, let's move forward to the next section. We're going to study the properties of minerals. All right. And I'm going to ask you a question before I continue with the properties of minerals. Let's say you are in a concert, in a rock concert or reggaeton concert, whatever the case may be, and you went to the concert with one of your friends, but your friend told you, your friend went to buy a soda, right? So now in the crowd, it's very difficult to spot your friend. You don't know what your friend is, especially because there are a lot of people in there. So, what are some things that you could use, or what is something that you could do to find your friend?
The color of his clothes.
Very good. Diego, Emilio?
We can use the cell phone to call him and know where he is.
Yeah, that's a real good one, Emilio. But let's say we don't have a cell phone handy and we just have, to use our senses. How would you spot your friend in the crowd?
Look in the shoes.
Exactly, by looking at the shoes, by looking, like Diego said, by looking at the clothes, the color of the clothes. Maybe your friend was wearing a yellow shirt, white shoes, or yeah, black pants, whatever. So that those are properties, those are physical characteristics that we are going to look for when we are trying to find our friend. So the same way, we are going to use some physical properties to identify uh, or to differentiate the minerals, right? Okay, the first property is crystals. I would like someone to go ahead and read crystals for me.
Mimster,
Yes, go ahead. Emil.
crystal.
Oh,
Uh,
Jared. Remember, you can raise your hand, guys. Jared, go ahead.
crystal. Solid materials that have a repeating pattern of atoms.
Thank you very much. So these are solid materials, and they have a specific pattern, and this pattern is arranged in a repeated way. Okay. And some crystals have smooth surfaces, called crystal faces. And for example, you can look at the example on page 168 in your book. On figure 3, you are able to see a mineral called pyrite, which is often called fool's gold. Why do you think this is called fool's gold?
Um,
Look at the picture over
because
there. Yeah, I
because
mean,
it looks like gold.
it looks like gold, of course, definitely, but it is not gold at all, right? So that's why it's called fool's gold. And it says it has um the shape of the crystal is with 6 faces, and you can see it over there. It
a
looks
cube.
like a cube, exactly. Thank you very much. All right, another property, or another two properties, are cleavage and fracture. And I'm gonna need someone to read cleavage and fracture. Emil.
Cl-
Me,
okay. Cleavage and fracture. Minerals that split into pieces with smooth, regular planes that reflect light are said to have cleavage. Minerals that break into pieces with jagged or rough edges.
Thank you very much. So in this case, we are looking for two characteristics, so for two properties in here, cleavage and fracture. You can see the examples on page 168 as well. All right, so cleavage is like, if the mineral is able to split into pieces, and these pieces are smooth and they have regular planes that reflect light, this is cleavage, right? But if some minerals break into pieces and these pieces are rough, or they are irregular, we can say that these minerals have fracture. So cleavage and fracture are opposites. Okay, guys, um, you can see the mica on page 168. It says it only has one direction of cleavage, and it can be peeled off in sheets, and it's smooth. And you can see the fracture and figure C, and that is it is irregular, it's jagged, and it's also smooth a little bit over there. Okay, so those
and it's
are
like flint.
yeah. Hold on, give me 1 second. The next one is the color. Color sometimes can help us, figure it out what a mineral is, right? So I'm not gonna get into color that much because we already know what color is. So for example, on page 169, 69, we have some minerals over there, like it says the mineral calcite can form in a wide variety of colors. The colors are caused by slight impurities. So some have this reddish gold color, somehow like a yellow color, and some other may even have blue color. They may have different colors, right? So we sometimes use color to identify what type of mineral we're talking about, right? Another one is strake and luster. Strake is who wants to read strake and luster?
Me.
All right, Emilio, go ahead.
Strike and luster. Strike is the color of the part mineral. Luster describes how light reflects from a mineral surface.
Thank you. Well, it's actually, hold on 1 second, guys. It's streak, not strike. Streak and luster. All right, hold on. All right, so streak is the color of the powdered mineral. If you see the picture, figure 6, it is the color of the powdered mineral. You can see two minerals over there, and you can see the powder over there, right? Or if you use something else, for example, um, if you use like something to scratch or scrap the mineral, you will get the streak. And the streak does not necessarily have to have the same color as the mineral itself. All right. And this is actually a better way to identify a mineral. The streak is it's more useful for identification than the mineral's color. Okay. For example, it says over there the gold prospectors could have saved themselves a lot of heartache if they had known about the streak test. Pyrite makes a greenish black or brownish black streak, but real gold makes a yellow streak. So that's a big difference. So that's a way to, um, you know, that's a way to differentiate fool's gold from actual gold. All right. And the luster describes how light reflects from a mineral surface. In this case, we can look for, you know, if the mineral is shiny, if it's dull, if it's pearly. Those are characteristics that will tell us about the luster of a mineral. Okay. Some minerals may have like a metallic luster. Some others may have a non-metallic luster, and they can be described as pearly, glassy, or dull. All right, or earthy luster as well. Okay, give me 1 second, please. Let me move forward. Okay, then we have the hardness. Some minerals are harder than others. Absolutely true. And there is a table on page 170 which shows the hardness of, it is a table that shows the hardness of the minerals. And you have like 10 different minerals over there and some numbers, and it goes from the softest to the hardest. Who wants to tell me what the softest is?
Talc.
Exactly. Thank you very much, Jared. And which is the hardest?
Diamond.
Diamond, of course. Thank you very much. And so this is a mass scale. In 1822, an Austrian geologist named Friedrich Maas also noticed this property of hardness, and he developed this way to classify minerals by their hardness. Okay, it classifies minerals from 1 to 10, like I said before, and the hardness can be determined by trying to scratch one mineral with another to see which is harder. And we can use, like, you know, homemade mineral identification things, things that we have at home, like a penny, a nail, and a small glass plate, right? And so we simply have to find out what scratches what, and we also have to find out if the mineral is hard enough to scratch a penny, and if this mineral will scratch a glass as well. All right. So another property is specific gravity. Who wants to go ahead and read specific gravity? Hello?
Yes.
Lauren, go
Okay,
ahead.
okay.
Lauren?
Compares the weight of a mineral with the weight of an equal volume of water.
Thank you very much. So yeah, when it comes to measure the specific gravity of a mineral, we are supposed to compare the weight of this mineral with the weight of an equal volume of water. And obviously, all minerals have different weight, you know, and as a consequence, a specific gravity. All right. Now we are going to see, this is the table that we were talking about, but in this case, I am presenting you a picture of each mineral. This is talc, which is one,
Beautiful.
yeah, this is the softest, and it is represented by 1. This is gypsum,
Mister,
yes.
a mineral can be the gold.
A mineral can be what, mister?
Gold.
Gold is a mineral, of course.
And zinc.
Yeah. And so we have
Okay.
gypsum represented by 2, calcite represented by 3, fluorite represented by 4, and apatite represented by 5, feldspar represented by 6, quartz represented by 7, topaz represented by 8, and corundum represented by 9, and diamond represented by 10. So remember, this table measures the hardness of each mineral. Okay, so because not all the minerals are in here, remember there are like around 4,000 minerals already identified. So for the rest of minerals, we use this table to determine the hardness. All right, we can say, for example, a mineral is a 1 or 2 or 3, 4, 7 of hardness, depending of the mineral we are studying. So this is an example of how can we identify the properties in a mineral. In this case, we have a quartz over here, and the crystal shape is hexagonal. The luster is non-metallic, like vitreous. The color is clear to milky, which means that it's clear, like transparent, but it's not real. It's not like completely transparent, so it's like kind of a milky as well. I'm sorry. And streak is it has no streak. Hardness is 7. Okay. And cleavage, it doesn't have cleavage. Fracture, it says the fracture is conchoidal, and the specific gravity is 2.65. Hold on one second, guys. All right, let me move to the next section. Okay, common
Pixel.
minerals. Who wants to read common minerals? Raise your hand. Adelson.
Most of the rock-forming minerals are silicates, which contain the element silicon and oxygen. More than the half of the mineral in air crust are formed of a silicate mineral called feldspar.
Thank you very much. So most of the rock forming minerals are silicates, and more than the half of the minerals in Earth's crust are forms of a silicate mineral called feldspar. All right, so this is why it is very important. Someone to read the second one, please. Raise your hand. Well, I believe Diego was raising his hand before. You can go ahead and read, Diego.
Other important minerals are carbonates or compounds containing carbon and oxygen.
Thank you very much. So some other are carbonates, which are compounds containing carbon and oxygen. Um, an example of this compound is the calcite, right? Which is uh, it makes up the common rock limestone. Okay. All right. Someone to read the next one, please. Did someone raise his or her hand? All right, I'm gonna call on someone then. Oh, who was raising the hand that didn't see? Let me see. Oh my goodness, I can see. All right, so Jared, go ahead.
Okay. Other common minerals can be found in rocks that form at the bottom of ancient evaporating seas.
Evaporating says. Okay, thank you very much. And yeah, so these minerals are mostly gypsum. Well, gypsum is very abundant in many places, and rock salt made of the mineral halite underlines large parts of the Midwest. as well. All right. Thank you very much. Let me see. These are examples of some common minerals. This is actually calcite. Hold on one second. Yeah.
So difficult to find.
Yeah, they may look like the same sometimes, right? But this one is feldspar, the first one, and the second one is calcite, and the third one is gypsum, and well, the last one is gypsum. Yes, Emilio.
In the book looks like a piece of glass.
I'm sorry.
In the book looks like a piece of glass.
Which one?
Calcite.
Calcite. Oh yes, exactly. So it looks like this one over here, right?
Yes.
Yeah. Thank you very much. All right. So gems and ores. Where we'll actually, this is the last part. We are running out of time, but we're going to try to finish. I was actually trying to separate you in breakout rooms to go ahead and discuss the section 1 assessment. We're going to go over gems and ores very quick. Gems are minerals that are rare and can be cut and polished, giving them a beautiful appearance, like diamonds, right? And these are often used, I'm sorry. Um, these are often used for jewelry, right? Like necklaces, bracelets, things like that. Mostly women wear. All right. And on the other hand, an ore is a mineral that contains enough of a useful substance that can be sold for a profit. As what are some of the examples in the book? That is on page 173.
The copper ore, mister.
The copper, exactly, the galena, the hematite, and also the
The
magnesium used in
jamestones.
vitamins comes from dolomite. And which one?
Jamestone.
Yeah, gemstones are like the gems, right? Which is something that I am going to present to you here. We have like most common gemstones: diamond, sapphire, ruby,
Iron.
emerald. Well, but these are gems. Iron is an ore.
Yes, of an ore, I'm saying.
Yeah, but we are going the gemstones right now. The picture that I am presenting over
OMG,
here.
are so
Opal,
beautiful.
yeah, amethyst, circle. Yeah, they are so beautiful. Yeah, Jared, and this is why they are mostly used or for jewelry, like necklaces, bracelets.
Mister.
Hmm.
Emerald like in Minecraft.
Yeah, at top, as you can see, all of the gemstones over there. And on this side, we have like some of the ores. This is,
Bullframe.
yeah, this is iron. I mean,
Uh,
not iron. It's
For
Bullframe.
melting.
yeah, this is hematite, which is used to make iron. It looks
Okay.
like this galena, but what's gonna be a difference between this one and this one? A
The
physical difference. Uh-huh.
one is mostly like iron and the other is more deformed.
Yeah, it's basically the luster because this is shinier, I would say, and this is like dull somehow. So that's a difference. And this is and the galena is used to make LEDs for batteries. And this is dolomite, which is used to extract magnesium, which is used in vitamins. All right, this is everything for today. But before we
You're welcome.
leave, I'm gonna try something because we were supposed, guys, to cover the section 1 assessment in groups. Let me stop sharing first, and let me stop recording as well.